Good evening, viewers. Welcome back to Supreme Online Lectures. Please endeavor to subscribe to our channel and also make a comment on the comment section in order to enable us improve on the subsequent videos that we will produce. All right, my name is Basi Eka. Today we are going to discuss on the topic Dimensions of Physical Quantities. Dimensions of physical quantities. For you to be successful in this topic, you must master your SI unit at your fingertips. Aside from that, you should understand the SI or mathematical expressions for some quantities. So if I say speed, you should know the mathematical expression for speed. If I say velocity, that's a quantity. You should know the mathematical expression for velocity. If I say acceleration, you should be able to understand the or to memorize those things. Those are basic things that you need to know. And with that, and I mentioned the SI unit. That is when you will excel in this very topic. Let me move down. Definition. The word dimensions denotes the physical nature of a quantity. So whenever we talk about dimensions, we are referring to the physical nature of that quantity. We can as well define it this way. The dimension of a physical quantity is the number of occurrences of the fundamental units of mass, length, and time in the physical quantity. The number of occurrences of the fundamental units. When we talk about fundamental units, we are referring to this is the example, mass, length. I'm trying to make corrections here on time in the physical quantity. All right. So these are basic units in physics, the mass, length, and time. Whenever I'm talking about mass, I'm referring to the quantity of matter in a substance. Length tells us about the difference between 2 points. And then the time tells us about the period in which an event occurred. Okay, let's look at the next definition here. The powers to which the fundamental quantities are raised in order to represent the quantity. This is also another way you can define dimensions of physical quantities. You define it as the power to which the fundamental quantities are raised in order to represent that quantity. So these three definitions, as we continue, you will really understand what I'm trying to say. So I would expect you to watch this video continuously in order for you to get a good understanding of what I'm trying to say. Before I continue, in physics, if I just write here, let's say I write here 10. I write here 10. 10 is a number. That's a number. I write here 20. That's a number. I decide to write 30. That's a number also. If I come behind this number 10 here and I introduce n, of course, anybody will know that I'm now referring to a currency. So automatically, this n here, it's the same, it plays the same role of, how do I put it? The SI unit. So the n there tells you that this number 10 is a currency. I remove this 10. I come here and I include S. What quantity is that? So the S there is the unit. Let me spell it in full. Seconds. The seconds tells us about the quantity. And this quantity is what? Please, I would like you to think before I say it. This is time. So the second here is the unit of time. So the quantity is time. The unit is seconds. So as I said earlier, for you to be successful in this very topic, you must master two things: your SI unit and the mathematical expression involved. I skip this and I move to 20. 20 is just a number. But the moment I introduce something, I write kg. It represents a quantity. And what quantity is that? This is the unit. This unit is telling me about a quantity. And what quantity is that? Mass. 30 is just a number. I come here and I then write meters. So meters there is a unit telling me about a quantity. What quantity is that also? It is talking about length. So this is length. This one is mass. So that's the quantity. This one, seconds. Time. Are you with me? Okay, so this is time. Time is the quantity. Seconds is the unit. Mass is the quantity. Kilogram is the unit. Length is the quantity. Meters is the unit. I hope you understood what I just explained. Let's go to the next point. To really understand this topic requires fundamental understanding of SI units, of quantities, and the mathematical expressions involved. I have already said that. The SI unit of a quantity is a language. When I see the SI unit, I quickly know what quantity it is telling me. So that's why I said that the SI unit is a language. There are other SI units, but I would like, let me see if I can just list them here for you to study. Hertz. Newton. Meters per second. Meters per second. You should be able to know what quantity uses the following. Meters per second square. Which other quantity should I mention here? Let me stop there. So try to think of it while we discuss other things. So the SI unit is a language. It tells us about the quantity in consideration. For example, if we say kilogram, what quantity am I referring to? I have already explained that. I want you to answer this. What if I say seconds? What quantity do I refer to? The symbols used in this section The symbols used in this section is to specify the dimensions of length, mass, and time. To specify the dimensions of length, let me put this well. Then mass, prefer using capital letters, so you derive something from it, and time. So if you look at here, I wrote L. This L here represents the length in dimensions. Look at it very well, this length. Then the next one here is capital M in dimensions, which represents the mass. Then the next one here is capital T, which represents the time. Remember the length here, the unit is seconds. So let me put seconds here so you don't get confused. So this is seconds. Then the mass, the unit is kilogram. And then the time, oh, sorry, I made a mistake. The time, the unit here is seconds. This one is meters. All right, so length, the unit is meters, mass, kilogram, time, seconds, respectively. This is what will be used to generate every other forms of dimensions. So in dimensions of physical quantities, we use the following to generate every other forms of dimensions we need. Look at the table. This serial number, SN, number 1. This is the quantity, mass. This is mathematical expression. Mass don't have expression, so I didn't put anything here. The unit here is kilogram. Then dimension of mass. Look at this place, mass. Pick the first alphabet here, M, place in place of dimensions. So the M there, the moment I see it, I know it is referring to mass. The kg here is the unit of mass. So I have written mass in dimensions as capital M. That one is just a single quantity. It's a fundamental quantity. When we get to derived quantity, it will require combination of fundamental quantities. So we would also combine the dimensions also in order for us to get the correct dimension for that quantity. Length, the unit is meter. So look at M here for unit. And then you pick the first letter here for L to represent the dimension, capital L. Time, the unit is seconds. We'll pick the first alphabet here, or the first letter here to represent the dimension of time, which is capital T. So whenever you see seconds, it means it is talking about time. In place of seconds, you are going to replace capital T. You just substitute. In place of meter, as a unit, you are going to replace capital L. In place of kilogram, you are going to replace capital M. Let's move down. The next quantity we have here is force. So as a student, you are expected to know the SI unit of force. And then the mathematical expression of force. With that, you can combine them together and then you will come up with something. Let me start with this other one, speed. So I delete this from here and I bring it here. And now move speed. Let me move this one to this point. What is speed? Distance all over time. Rate of change of distance with time. So speed, S, equals to the rate of change of distance with time. Okay. All right. What is the SI unit of distance? Meters. What is the SI unit of time? Seconds. So here, I would only write in place of units, meters per seconds. What's going to be the dimension of speed? Look at this one. Here we have M. What is M? In dimensions, you are going to replace the M with the capital letter L. You now have L all over. The S here represents seconds, which is time. L all over T. The next quantity here in consideration is force. So let me bring this one here. I have my reasons for shifting it. Let me put this one here. What's the mathematical expression of force? Force, F, equals to mg. That's mass times acceleration due to gravity. All right. So as a student, you are expected to know the SI unit of mass. You are expected to know the SI unit of mass, which is kilogram. And the SI unit of acceleration due to gravity is meters per second square. Let me put this well. Meters per second square. Okay. So under the units, look at it. Under units, we are going to pick just the kilogram here, the mass here, and the time here, and we keep it in one place. This is what I mean. Please try to understand me. Permit me to write this equation very well for you to understand. So you have to give me a little time. Hope you are still with me. Don't go anywhere. Okay. This should. All right. So kilogram times M times M, the unit of acceleration, all over S square. All over S square. Let me pick something from here. Okay. So this is S square. Now, the next thing we are going to do is to replace the dimensions of mass in place of kilogram. What am I going to put in place of kilogram? I think you should know that. L. So in place of M, I am going to put L, and then in place of S square, I am going to put T square. So let me pick this one here in place of kg. In dimensions, these are units. So in dimensions, I am going to put capital M for mass. Then small m stands for unit of length. So in place of m, small m, I'm going to put L. And then I come down here in place of S for seconds. Second stands for time. I will remove this and put time. So the moment I see this, I understand that this is dimensions for force. If you don't write it this way, you can write it as ml t to power minus 2. I don't know how fast I would be in typing. Let me put it ml t to power minus 2. To power minus 2, where the negative sign comes from is as a result of indices. Remember, in indices, if we have 1 over, let me go to the board so that you understand what I'm trying to say. Give me time, let me switch to the board. Okay. All right. In indices, if I say 1 all over k, it is the same thing as saying k to power minus 1. So the 1 over here, there is division sign in indices is written as power minus 1. If I say 1 over k square, in indices, I can write it as k to power minus 2. Please, we are going to apply this method here. Are you following? We are going to apply this method here. So let's go back to what we were doing. I had 1 over s square, 1 over s square, 1 over t square. So the t square, 1 over t square can be written as t to power minus 2. That's another way of representing the same quantity. So you see that I write it this way, or I write it this way. Let's go to the next one here is momentum. What is momentum? You have to recall the mathematical expression. Let's see. So momentum, P, is the product of mass and velocity. When they say product, what does it mean? You're multiplying two quantities, mass and velocity. Product of mass and velocity. What are we going to do? As a student, you are expected to know the SI unit of mass and that of velocity. Most students don't even know the difference between a mathematical expression and SI unit. So please, I am pleading with you, go back to the fundamentals and study those things. If not, you would not excel. Okay, let's come here. What's the unit of mass? I believe you're going to tell me from where you are watching from. This is kilogram. Velocity and speed have the same unit. So the unit of velocity is what? Let me pick something from here. Meters per second. Meters per second. Now, since we are multiplying mass and velocity, we are going to also multiply the two units. So we would have kilogram times meters per second. So I'm going to write it this way. Let me first carry this. So this meters per second. Kilogram should come first. Kilogram times meters per second. So this is a combination of the unit. So the kilogram here stands for mass, and the meters per second stands for velocity. So this is a complete way of writing the unit of momentum. Now, we are not going to end there because what we are doing is dimensions. So we are going to interpret this unit in dimensions. Let me copy this one to the other side. In place of kilogram, tell me, what am I going to put? If you're following what I'm trying to say. Kilogram, capital what? M. Then in place of small m represents length. So I'm going to put capital L. S, seconds, representing what quantity? Time. So if I see ml all over t, this is the dimensions for momentum. If I don't write it this way, then I am going to write it as ml to power minus 1. Remember, I have told you before now that when you have an item like 1 over t, in indices, you can write it as t to power minus 1. So this one would be ml t to power minus 1. Remember, there is an invisible one here, up here. That is, but since it's just a single value, we are not going to write 1 here. So that 1 is what you're writing here. Don't begin to imagine where the 1 is coming from. We are not magicians. All right, finally, work and energy would have the same dimensions. What is the formula of work? As a student, you have to remember that work is mgh. Or what is mg? Force. Remember, I've done this. That was why I had to shift this one. Force is ma, product of mass and acceleration. That's what I'm trying to say is this still equals to, I can simply say W, which is work, equals to force times height. So the mg takes the place of F. All right, so now What I'm going to introduce now is the SI unit of force. Since I've already treated this, I don't have to come and start doing this again, bringing mass here and then all of that. So let me just carry this. So in place of the unit of force, I am going to replace this one. Discard that. Please bear with me. What do I do now? I want to group it so that you understand well. Let me W, that is work, is equals to, let's go to the board. Let me switch to the board. Let me pick some things here. So when I'm switching, I can still get what I'm looking for. I'm coming. Force, kilogram meters per second square. Okay, let me switch over now to the whiteboard so that I can write well. The space I have there is small. So I said that work W equals to product of force times displacement. Now, work here is equals to the unit of force. What was it? Kilogram meters all over second square. You remember? Times D. What is this D? What is D? Displacement. Okay, so what's the unit of displacement? If I may ask, what is the unit of displacement? Displacement and distance have the same unit, but displacement is a scalar quantity, a vector quantity, while distance is a scalar quantity. Displacement has direction, distance does not have. Displacement has both numerical values and direction, while distance has only numerical values. When I say numerical values, I'm talking about numbers. All right, so the unit of displacement is M also. Hope you're seeing. So W is equals to kilogram meters all over S square times M. What is M times M? M times M will give me M square. So in order for me to save our time, I clean this and I just write M square. Are you with me? So in place of this, I replace this 2 big O. Use what I was using. All right. Now, the next thing I'm going to do is to convert this to dimensions. What's the dimension for kilogram? Kilogram stands for mass. Meters is length, so dimensions is L. We have square here, so I will now write the square here. All over S square. S is what? Time. And I write T here to power 2. I'm now going to stop here. So remember, if we don't write it this way, we would write it as ml square. Since this one is divided by t square, we'll just write ml square to power t, ml square t to power minus 2. So let me bring it here. We'll have L squared t to the power minus 2. This is the dimensions. ML square, ML square t to the power minus 2. Let me switch back to the table. So I've solved all these ones. We'll now have let me bring this one here. ML square. No. I want to raise this to power. So how do I do? What do I do? Please, I'm coming. Give me time. ML square t to the power minus 2. So this represents, sometimes they may decide to ask you dimensions of energy. Always remember that energy is work. So you don't see yourself, or they don't take you off balance. Assignment. Generate the following. Impulse. Generate dimensions for the following. Impulse. Impulse, the formula is Ft. I think I've given you hints, something that will help you to get your own dimension. The next one is pressure, force per unit area. So this is the formula, F over A, force per unit area. Use that to generate volume. This is the formula. Hope you remember. Let me clean it. So this is your assignment. Other assignments. Moment of inertia, angular acceleration, speed, acceleration due to gravity. I think I've done velocity. Hope it was speed, velocity, acceleration, and power. Please, thank you very much. If you have learned something from our channel and you really enjoyed it, please I want you to go down to the subscribe button and just click on subscribe in order for you to encourage us to do more. Thank you so much. If you have friends, please endeavor to share to your friends. I really appreciate your stay. Have a wonderful day. Bye.